All right, day 19. Let's make this thing work. Hopefully it won't be too bad, but probably it will be. So we'll see what happens. Your scan showed that lava did indeed form obsidian. I should probably pay more attention to these stories. I'm just like speed reading these to find the problem. I have no idea what's going on. Something about elephants and lava. The wind has changed direction, stopped. You notice a collection of geodes. First, use the obsidian to create some geode cracking robots and break them open. To collect the obsidian, you'll need waterproof obsidian collecting robots. First, you need a abundant amount of clay and make them waterproof. To harvest the clay, you'll need special clay collecting robots. You need ore, which is also plentiful, but the opposite direction of the clay. Collecting ore requires ore collecting. Unfortunately, you have exactly one ore collecting robot. Each robot can collect one of its resource type per minute. It also takes 1 minute for the robot factory. Also conveniently from your pack to construct any type of robot, although it consumes the necessary resources available when construction begins. Our factory has blueprints you can choose from, but once you configure it with a blueprint, you can't change it. You need to work out which blueprint is best. Which obsidian robots? The robots, you need to figure out which blueprint maximizes by figuring out which robots to build. Using blueprint 1, one way to achieve that is minute 1, one ore collecting robot collects 1 ore, you now have 1 ore. One ore collecting robot collects 1 ore, you now have 2 ore. Spend 2 ore to start building a clay collecting robot. 1 ore collecting robot collects 1 ore, you now have 1 ore. The new clay collecting robot is ready, you now have 1 of them. Minute 4, 1 ore collecting robot, you now have 2 ore. Spend 2 ore. Okay, we're using blueprint 2, even better, large number. All right, so this seems involved. Obsidian robot is always ore and clay. Geode robot is always ore and obsidian. Okay. So, blueprints have been lined up for legibility. That's an irritation. So let me do this, and it's going to be a huge nuisance, and it's just going to be one space. So I'm going to waste a lot of time doing this. Okay. And I'm in the wrong file, which is good too. So let me put this here, and while I'm at it, I might as well just grab this and put it in the text file so we have it. Okay. So now, and I want this to read because okay. Okay, so again, import RE. And let's say regex equals blueprint zero to 9 plus each ore robot. Actually, let me just copy that. Whoops. Robot costs, or each clay robot costs 9 plus, or each obsidian robot costs 0 to 9 plus, or, and from data classes, import data class, class blueprint, and what do they call that? An ID? ID number. ID, which is an int. Or robot or cost, which is an int, or cost. Clear robot or cost, which is an int. Obsidian robot or cost, which is an int. Obsidian robot clay cost, which is an int. Geode robot or cost, which is an int. And geode robot obsidian cost, which is an int. Okay. And I'm going to static method, not class method. From string becomes a blueprint. Is that true, or should matches start with 0? Let's say match equals re dot match regex comma s. I don't like calling things string, just call it s. Return blueprint match group, I think, right? Okay, if match, okay, else, okay, and let's say blueprints equals, so let's run this and see if it works. Okay, that didn't work. Valid literal for ints. Okay, lines equals raw dot split lines. Line equal line 0. Re dot match regex line. M equals that. Dot group. No. M dot groups. Oh, it was groups. It shows you how well I know the regex API. Okay, so that seems good. So now, let us go figure out what the problem wants us to do. You know, exactly one or collecting a robot, use get to the operation. Okay, so we also need when I stick things on the stack, I like to make them compact, so I'm going to use the name tuple for this. Plus I'm going to be modifying, and name tuple will make this easier, trust me. State, which is a named tuple. And what does the state look like? Or, which is an int equals 0. Clay, which is an int equals 0. Obsidian, which is an int equals 0. Geode int equals 0. Or robots, clay robots, obsidian robots, geode robots. I think it's cheating, is what I think. But that's fine. Just increase some geode robots. One ore collecting robot collects 1 ore. Spend 2 ore to start building a clay collecting robot. New. Okay. Spend 2 ore to start building a clay collecting robot. Spend 2 ore to start building 3 clay collecting robots. 1 ore collecting robot collects 1 ore. You know, 4 ore. 3 clay collecting robots collect 3 clay. You now have 15 clay. New obsidian collecting robot is now ready. You now have 1 of them. And time int equals 0. And then from collections import deck, Q, which is a deck, which is, so let's think about this. After 24, you blueprint 1. Each robot can collect 1 per minute. It also takes 1 minute for the robot factory to construct any type of robots. The robot factory has many blueprints, your puzzle inputs, but you can choose from, but once you configure it with a blueprint, you can't change it. You'll need to work out which blueprint is best. 1 minute for the robot factory to construct any type of robots. Okay, so I don't think I need a queue. But I can only build 1 robot at a time, so I think that's that. Okay. Okay, def next states self, which is going to be an iterator of state. States self blueprint, which is a blueprint. Okay, so new time equals self.time plus 1. New ore equals self ore plus self.ore robots. New clay, new obsidian, new geode. Okay, so that's good. And then, so one thing I can do is build nothing. So yield state dot replace time equals new time or equals new or obsidian g equals new geo. Okay. Self dot replace. Okay, so this is why I like using name tuples in this particular circumstance. Is when I have like an object and I just want to change a few of its things, I can use this replace method and get a brand new object. Whereas if I was using data classes, I would have to like do a copy and then construct. Anyway, this works better. Okay, build or robot. if I need the or at the beginning, if or is bigger than equal to blueprint or robot or cost, yield self-replace or equals new or minus, and I think I need the or at the beginning of the period, so let's make sure that's right. Anyway, well, self-place, blueprint, clay, or robots equals self or robots plus 1. So yes, that's right. Build clay robots. If there is no clay robot clay cost, so we don't need that for sure. Yield self-dart place or equals new or minus clay robot or cost, clay equals new clay obsidian, g equals new geode, clay robots equals self.clay robots plus 1. That seems right. And this should be self.or. That was why it's complaining at me. Build obsidian robot. If self.or is bigger than equal to that, and self.clay is, okay, now we have an obsidian robot has a or cost and a clay cost, so that's right. Self.replace time equals new time, or equals new or, clay equals new clay, obsidian equals new obsidian, geode equals new geode, obsidian robots equals self.obsidian robots plus 1. That seems right. And finally, build a geode robot. If self.or is bigger than bluepot and self.obsidian, obsidian cost, time, new time, clay equals new clay, obsidian, new obsidian, that seems right. Okay. And this is going to be another, we'll try it, but we're probably gonna have to change it to be another quote unquote A star search where we say, you know, let's overestimate the most geodes we could get if we behaved optimally from now, see how much geodes we've gotten so far, and pull them in that order. And then once we can't get more than that optimal thing, then we won't do it. But anyway, we'll, yeah, I better do that anyway. From heap queue. I'll just do import heap queue. And let's say def overestimate max geodes. Okay. 24 minutes, 24 minutes, 24 minutes is always 24 minutes. X time, and which is 24. Okay. Remaining time equals max time minus self.time. Or let me do this. Geodes equals self.geode. I'm just going to do a really gross overestimate and see if that is okay. Time equals self.time. While time is less than max time, time geo plus equals self geode robots, and then I'm also going to do say geode robots equals self.geode robots, geodes plus equals self.geode robots, or geodes plus equals geode robots, and this is going to be a way over estimate, and I'll come back and fix it. Geode robots plus equals 1, return geodes. Okay. Okay. And now def max geodes, which takes a blueprint, which is a blueprint, and let's say int, and let's say q equals this, state equals state, and best equals state dot overestimate max geodes blueprint. Yep. Let's say I'll call it OMG minus OMG best equals -1. Pop off the heap for new state in state's next state blueprint. If new state geode bigger than best, best equals new state dot geode. Let me do this. OMG if negative OMG is less than best, return best. For new state, if new state geode is bigger than best, best equals new state geode, and then regardless, I want to push. That seems right. Let's see if this works. It doesn't. Okay, let's run this and see what happens. Let's try this again. ore collecting robots. You have one ore collecting robot in your pack, so that is the problem, is that ore robots should start off at 1. Okay, so now let's run it again. Let's look at this. Okay. So one thing I could do is the following. Robots equals state dot geode robots, and let's see if this hack works. Priority equals minus new state dot geode robots minus new state dot minus geode. Okay, that's good. Equals new priority. And then there was one thing I wanted to change, which was there was something else I wanted to change. What did I want to change? I can't remember. I'll figure it out. That was what I wanted to change. Actually, I need to do it in the other direction. Because I do want this to be the highest priority, which is fine. I think that's okay. Okay, so now let me do the following. Def priority self blueprints, and it's not going to return it, and it's going to return a tuple. And I want to do the following. Return yes, 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 Yes. I don't think that matters, but that's fine. States G equals priority 0. All right. If this doesn't work, I'm going to run out of ideas pretty soon. Okay, so I would never want to build nothing, right? So I only want to build nothing if I have to. Is that true? No, I might want to build nothing, but only do this if I, so let me think about this. So, okay, and property max or needed self int return max of no, that doesn't seem to work either. Problem is I'm collecting way too much. I'm building way too many ore robots, I feel like, and not enough obsidian robots. And so this first one's not actually biting. Okay, so each. Well, I'll do that anyway. And I don't need to print that new state because that's just giving me too much stuff. So let me get that. Average number of GAs you have in 24 minutes is 9. And I still have no geode robots. So let me just change this a little bit. I don't care about clay robots, I care about clay. And let me try this again. Okay, well that's one problem. The good thing about this is that's the other reason to use name tuples, is that I can keep track of them. If new state in scene continue, else scene.add new state. Okay, so let's try this because I notice that I'm repeating a lot of stuff. No, I'm definitely going up higher in time. So this says the best I can do is 9, which is true, I think he said, right? And then for the second one, it says it should be 12. So let's try that. This is not super fast, but anyway, if this runs for a while, I'm okay with that, as long as it gets the right answer. Although let me look at the, there may be some real big numbers in here that, it seems about par for the course, right? minus 15. All right, we're getting there. We need to get to minus 12. What am I using as my priorities? Because the problem is it's taking me forever to get to a geode robot, right? And okay, so let's think about this slightly more, which is def distance from geode robot self goes to int, okay? And blueprint, okay, which is a blueprint. So, okay. So let's say obsidian needed equals blueprint geode, okay? Okay. Let's say steps from geode robots. Okay. Okay, so have an or robots. Okay. And let's say steps equals 0. If self dot clay needed equals blueprint, or no. If self dot geode robots bigger than 0, return steps. Otherwise, each geode robot costs otherwise or needed equals blueprint dot geode robot or cost. Obsidian needed equals blueprint minus self dot obsidian. If obsidian needed this is going to be hard. I'm going to skip it. What if I just take out the print statements and print new best new state. Okay. And then let me take out all of these because they're slowing things down. do one more thing, which is if priority 0 is bigger than OMG, prints OMG equals priority 0, print minus OMG state OMG, and then if minus OMG is less than best, return best. I don't know if I may have broken something there, so we'll see. I screwed that one up too. Let's see, best OMG equals OMG. OMG is bigger than best OMG, print new OMG, OMG. Yeah, okay, let's do it that way. And let me make sure this is working. Nope. That's what I'm looking for. Yeah. Okay, so that ran. All right. So finally, let us go back to this thing, quality level. Quality level is ID times that. So def quality level blueprints max time. Okay, so this is not right at all. And so qualities equals for let's do return max blueprint times blueprint dot ID. What do you get if you add up the quality level? Okay, so total quality level blueprints. Okay. For blueprints in blueprints print blueprints QL equals okay with open day19 dot text as f raw equals f dot read blueprints equals yep print total quality level blueprints 24. All right, let's run this. It might take a while, but that's all right. Okay, well, if it gets to an OMG of 0, then it's going to be 0, right? Does that seem plausible? Okay. Or by clear rock has 4 or 18 clay. Well, we'll try it. So let us go back and add another thing, which is if OMG equals 0, then return 0. Okay, so let's try that again. So we got to go through 30 of these. I hope I was aggressive enough in printing. It's going to take a while, but that's all right. We can, as the commenter said, if I was smarter about this overestimate max geodes, oh, so he was just saying I should have a closed form for it rather than doing it, which is fine. That wouldn't, I mean, this is only going to be 20 steps, so it's not going to save me like a ton of time. What I was thinking was this is not a very tight mount, because the reality is that I'm not going to be able to build a geode robot at every time step. That said, like coming up with a tighter bound basically involves solving the problem again to figure out how many I can build. So I don't know that I have a great idea for how to do that. I may as well just let this one run. And it's thinking it's going to take about 10 minutes at the current rate it's going. But yeah, wish I could look ahead to see what part 2 is. Anyway, I'm not going to burden you with watching this. So I'm going to stop streaming, and then I'll come back after it finishes at some point and do a part 2. And hopefully part 2 doesn't take quite as long. So that's that. See you in a bit.